In this presentation we'll have a look at the adversarial role with inside pen testing, and that can involve looking at user accounts and also the enumeration of hosts on the network. Okay, so this is our model. We have an evaluator with our bag of tools, and we'll come back to Nessus a little bit later in this presentation. And really what we're looking for is vulnerabilities, and then the adversarial role looks to exploit that vulnerability. Although vulnerability might be there, it might not be possible to actually exploit it. So at the adversarial stage, we look to go to the exploit. Might not be to do damage, it might be just to make sure that it is possible to exploit and then stop at that stage. Okay, so if we recap, this is what we had before. We do a technical scan for vulnerabilities using Nmap, Nessus, hping and so on. We do our port scanning, our malware detection, our database exploits and so on. This is typical standard probing of the network and so on. And then it's important that we look at the reports and be able to actually understand what the results actually are saying. We might also do a business scan for vulnerabilities for human social engineering, password cracking, data theft and so on. So the tools that we use typically are Nessus, Nmap as we've seen. The Microsoft Baseline Security Analyzer is a tool that will allow us to be able to see if we have any security faults with inside in our own host. Then there's Saint, which also gives us a report of the vulnerabilities on a host. We get tools such as Superscan. Superscan is able to do a scan of a network, looking at IP addresses, looking at the hosts that are alive, and then can do a whole lot of other things like look at user accounts, MAC addresses, null session, and so on. NetStumbler is used for wireless scanning, and that we can actually see all the open wireless access points that there are, and the associated frequency of transmission. And Kismet, which is an IDS sniffer for typically for wireless systems. Okay, so if we go through the first two stages, the technical scan and the business scan for the vulnerabilities, the next stage might be if the organisation want us to go to the adversarial role. So there might be a certain key objective that we're trying to focus on, such as adverse disclosure, service availability, business disruption, fraud, e-crime, reputational damage, legal and regulatory censor, and so on. And that's really the focus of our adversarial role. We would pick out one or more of these for our aim, and then we might look to a denial of service, user account breach, password cracking, physical attack, database breach, email breach, SNMP breach, and so on. So all these might be some sort of breach, install, compromise, and the end result will actually prove if the vulnerability can actually be seen through to cause some sort of damage. It's then up to the organisation to make sure that it can actually stop this from actually happening in the future, and make some sort of progress on this. So we'd often make sure that our security devices are up to date and actually being able to scan for all these types of threats. Okay, so one area that can be a weakness in a system is when we use weak usernames and passwords. So a package such as Hydra is able to try lots of usernames and passwords to be able to try and crack at least one username and password. So it's important that we understand what that traffic actually looks like. So what we'll do is we'll scan our Nessus account again. So we'll bring up our VM. So I have Metasploit here. Just taking a little minute to bring back the screen. Okay, so here we are, and we're at 147.33. Okay, so what I've done is I've prepared a sample username, typical usernames, and also for typical passwords. To save time, I've not created a long list, but these are some sample passwords that we might get, some of the most popular ones at one time. And then what we can do is that we can actually run Hydra against the Metasploit image. So in this case we're scanning for 133.47. Okay, so what's going to happen is that Hydra is going to read from that user file, take one user at a time, try all the passwords, try the next user, and so on. So that we understand what our trace looks like, so that we can actually detect it on the network. Let's run here, and I think we're on this adapter. Okay, so here we go. So what we're going to do is we're going to send that into, just disable Dropbox, it tends to get in the way. Okay, so we actually have an old session. So there is a hydra.restore which will restore an old session. So we'll just get rid of that, and then we'll start again from scratch. Okay. So then what we see is a continual connecting, and then we see it actually trying a whole lot of passwords. In this case it tries a few passwords, usernames and passwords, to be able to see if it can actually get into the system. And then eventually what should happen is that we get success, and here is the success here. So you can see here that it's managed to find that the user here is user, and password of user is one thing that we can use for our scan. Okay, so you can see it's continually trying and so on. So obviously it could stop when it gets to when it gets to user and user. So just so that we can check that that's the case, let's just use Telnet on port 21. User, and password user. Okay, so we're in. And so that actually shows that. If we look at our Metasploit log, and this is the one here, and we look at our high risk ones. Here's one that relates to FTP. There's another one, smiley face backdoor, which is critical, and then there's another one here for anonymous. Okay, and we get the detail here for it. And so all that is saying is that we should be able to put in anonymous. doesn't matter what we provide here, it's going to let us in. And there you go. Oh, and then we are in the top level folder then. Okay, so we'd often use an FTP client here to quickly connect. One and 192.168.47.133, port 21, anonymous, connect. And there we are here. Okay, so we've managed to connect to that. Okay, so it's important that we look at all our vulnerabilities and to be able to understand what they're saying. And obviously in this case we should really disable the anonymous login, because it gives a portal for an intruder to get into the system. Okay, so we can see that Hydra is able to do that for FTP, and the same can happen for Telnet. So we just define, we can now try on the Telnet port. So let's take our Warshak again. Let's erase the old trace. And here we go. Okay, so there we go. There's the Telnet. Let's follow a sample session. So let's try an administrator, and that's the password. There's another one, and so on. Okay, so you can see already it's found user and user as a successful login. So we should be able to search there and actually find out the successful login. So with Hydra we can assess with a whole lot of protocols. Or on a certain port, just by using the -s option, and it should be able to communicate with the protocol that we give it. Here we are, there's the service, so we can try Cisco, FTPS, HTTP, MSQL, MySQL, lots of different POP, lots of different protocols, and obviously when we do our nmap, it should return us back the services that we are interested in. And also for Nessus should also tell us which ports are actually open. Okay, so if you remember, if we just go here, there's the standard sign of nmap scanning the ports, and you can see our Metasploit image has got lots of ports open. So you can see, so there's a whole lot of services that are obviously open there, and we could obviously scan for some of these. Okay, so that's Hydra, and Hydra allows us to be able to scan for usernames and passwords, and it speaks the protocol. Another thing a tester might do is to be able to enumerate domains and hosts with inside domains and so on. Okay, so many machines will connect to a Windows domain, so it's actually important that we understand the architecture within inside a Windows domain. So let's actually start up our VM, our Windows VM. And we should be able to have a look at some of the commands used in here. Just takes a little minute to start up. Okay, while that's starting up, we'll look at this. So we've got, when we look at a net share, we can actually see all the shares. These are the connections that someone could make to our computer. And the IPC one is the inter-process communication share. That's for remote administration. And it's a hidden share that you don't actually see. But it is something that is possible to actually connect to. So we can view our domain, and our domain will actually show us all the domains that are inside our organizational infrastructure. And then for each domain, we can look at the hosts that are within inside there. And then on a certain host, we would look at the shares with inside that host if we obviously have the rights for that. Okay, so let's list the domains. At the top level we have a slash, and then we can list a specific domain, and then list a machine inside a domain. So let's see if our VM has started up yet. Okay, so our commands, as we remember, were net view domain. Okay, so there is only one domain here, and that's the workgroup. And then we can look inside that by looking at netview/domain. Okay, so we can see there are 3 machines which connect into that domain. So now we can actually do we can look at the shares within inside them. Well, we're getting an access denied. Let's even try it for this machine. And again, we get an access denied. So we need to join the domain to be able to see the machines there. But we'll have a look to see how that we can actually use this net command to be able to look at an exploit. Okay, so that's the 3 key commands within inside a domain. So there is a problem called null share, and a null share causes us problems, and it is possible for an intruder to connect to this IPC port. So let's look at our Nessus scan. And let's see if Nessus has identified that. Okay, so let's go through them. here we go. So the problem here is to do with the shares on the network. And we can see here that this image has problems because we can use what's called a null session, and we'll have a look to see what the null session actually is in a minute. And it's telling us what the files it discovered from them. Okay, so let's see if we can make a null session with that machine. Okay, so that's the IP address of the host that we've actually scanned. There's the IPC, and then to create a null session we can actually connect to it with the null user. Okay, so we then net use, and we can see here that we've now connected to it. So if we now try //192.168.47.133, we can see now that we actually have been able to use the null share. Okay, we've already discovered that that's a possibility. Okay, so that gives us, we've seen from the scan that it's actually possible to actually find that vulnerability. Okay, another command that we can then use once we have this null session set up is the user to SID. So let's bring up our console again. So user to SID, and we'll just put in the IP address. And we'll try and find let's try this again. 92.168.47.133 guest. Okay, so there's no guest account on there, but there is a user account. So let's see if we can enumerate the administrator, and we can't see that one. Okay, so the user to SID will actually resolve a unique ID for that account, and we'll have a look at that ID in a little minute. Defines the domain that it's in and the type of user that is actually using it. Then we can do the reverse. We can actually find out for a unique ID the actual username that resolves to that. And 500 is the administrator account, and 501 is the guest account. Okay, so dumpsec will also show us the shares that we have. We can also use the enum command to be able to enumerate a machine once we have the null session. Here it is here. And we're using the -PC. Get the password policy information. So it's 192.168.47.133. Okay, so it will actually tell us what the password policy is for the machine. In this case, a minimum length of 5 characters. any lockout thresholds or resets and so on. Another important program that we can use is called netbtstat. In this case, we can actually find out the net BIOS names that we've discovered. As we've seen with the // the names within a Windows domain are given these names, and we discover them from a NetBIOS name server. So in this case, we've discovered these two things. That's the domain controller is the one that will resolve these names. So that's a 1C, and a 1B is the domain master. And this really maps our domain names to a NetBIOS infrastructure. Okay, so to be able to guard against this null session, we actually need to block any incoming NetBIOS. So we'd block these ports which are used for NetBIOS inside the domains. We'd also disabled NetBIOS over the network, and there is actually another key that we can set in a registry to be able to restrict the anonymous login. So let's look in a little bit more detail at what makes up a Windows architecture. Okay, so as we've seen, there's a command called user2sid, which will resolve a username into what's called the user SID, and that's the unique identifier. The identifier actually identifies the domain number which the user is registered to, and then at the end we'll actually define the relative user ID. So 501 is a guest, 500 is admin, 1000 is the first user, and then so on. So in this case, we can use user2sid to resolve that, and then we can actually do the reverse, sid to user on a machine, once we have our null share, to find the name of the user for that SID and the domain. Okay, so in most organizations, computers connect to a domain controller, and the domain controller will control all the usernames and passwords for the whole of the network. This domain controller holds these usernames and passwords, known as a SAM database. The SAM database is mounted onto the registry, and it will control the access, the rights for a whole domain, and will manage all the password policies. Okay, so when we use NetBIOS, the ports that we typically use are 135, 137, 138, 139, and 445. So let's have a look to see if we can see that. Just run Wireshark. We'll do some NetBIOS activity. Capture there. There we go. Okay, so let's go and we'll just mount a drive, remote drive, do some stuff. Okay, so let's look to see what that gives us. Okay, so here are some of the commands that NetBIOS will use. SMB allows us to be able to mount a remote drive onto our machine. We can see this is using port 445. Okay, so if we look back here, 445 is SMB over TCP. Okay, so that's all the SMB commands, and that's we're mounting that drive onto our machine. And you can see a whole lot of that there. There's our ARPs. Okay, so there's another net BIOS on 445. Okay, so these are key ports for us. When we use within a Windows domain, we don't necessarily have to use TCP/IP. We can use net BIOS to be able to communicate. To make it routable, we use SMB blocks, and we can use TCP to route them within a Windows domain and across a Windows domain. Okay, so that's given us a basic introduction to some adversarial roles of enumeration and user accounts.